Welcome to Mathenatic. In this video, we'll focus on an exam type question for sequence and series. The following sequence is a combination of an arithmetic and geometric sequence. So we have 3, 3, 9, 6, 15, 12, and that pattern continues. Write down the next two terms. In the information, they tell us that this is a combination of arithmetic and geometric. So our job is to find out which parts are arithmetic and which parts are geometric. So do you notice that if this is a combination from term 1 to term 3, we are adding 6. Then from term 3 to term 5, we are adding 6 again. So that's a constant difference between every second term. Then from the second to the fourth term, we are multiplying by 2. And from the fourth to the sixth term, we are also multiplying by 2. So this type of pattern does take a little bit of practice to identify. But once we have that, we can find the next two terms. So term 7 would be 15 plus 6, and that is 21. And term 8 is 12 times 2, and that is equals to 24. The second question says, calculate term 52 minus term 51. So let's quickly discuss term 52. Can you see that every second term, so term 2, term 4, term 6, and so on, that forms part of the geometric sequence. So term 52 would be part of the geometric pattern, and it will actually be the 26th term in the geometric pattern. So we just take the amount of positions divided by 2. Take, for example, 3 here. That is term 2 in our original sequence, but it is term 1 in the geometric pattern. So that means that term 52 in the original sequence would be term 26 in the geometric pattern. If we focus on the geometric pattern, we can find the general term as Tn is equals to a times r to the power of n minus 1. A represents the first term in that pattern, which is equals to 3, and r is the ratio between terms, so we are multiplying by 2. And we know that term 52 is term 26 in this pattern. So therefore, term 26 is 3 times 2 to the power of 25. So let's move on to the arithmetic pattern. So term 51 in that pattern would be term 26 in the arithmetic pattern. So in the original pattern, term number 51 would be term 26 of the arithmetic sequence. So the first term now is 3. So the 3 they are referring to is the first 3 there. And the constant difference between terms is 6. And that is what I substituted in here. So we have A is equals to 3 and D is equals to 6. And the position we're looking at is term 26, not term 51, but term 26 of this pattern. So I replace n with 26, so 26 minus 1 is 25, and when I simplify, I have term 26 is 153. So if we want to find term 52 minus term 51, we say 3 times 2 to the power of 25 minus 153, and that is equals to 100,663,143. The next question is one that we see quite often. It says, prove that all the terms in this infinite sequence will be divisible by 3. So if you can prove that all the terms in the geometric pattern and all the terms in the arithmetic pattern are multiples of 3 or divisible by 3, then you would have proven that all the terms in this pattern is divisible by 3. So let's consider the geometric pattern. So can you see our A value was 3, so it's 3 times the ratio of 2 to the power of n minus 1. And because we are multiplying by 3, it's always a multiple of 3. For the arithmetic sequence, we have a plus n minus 1d. The a value was 3. The difference between terms are 6. And if I simplify this by multiplying out, I have 3 plus 6n minus 6, which simplifies to 6n minus 3. And can you see that we can take out a common factor of 3 as well? So that is, if I take out 3 in this expression, I have 3 times 2n minus 3. And this also tells me that this pattern, or the arithmetic pattern, is also a multiple of 3. So if all the terms in the geometric pattern is a multiple of 3, and all of the terms in the arithmetic pattern is a multiple of 3, then every single term would be divisible by 3. Thank you for watching. Support us by liking and subscribing to Mathenatic. Check out our Digistore for math study notes, with free downloads for statistics and financial math. Follow the link in the video description.